Mr. Minnick helping students with a really tricky set of questions, numbers 8, 9, and 10, that at least at one time in the teaching of this course were part of Array Multiple Choice Worksheet number 1. And here is question number 8. Now I'm not going to go over the answer yet. We're going to discover the answer as we think about it and trace this code. So in this particular code segment that probably would not execute because it doesn't have a main method, by the way. Anyway, it would compile, and that's enough. So what output will be produced by invoking, which just means executing or calling the test method for this tester object? So here's the test method, and let's go. I is a local variable in the body of the method. I'm just going to keep track of I and set it equal to 0 like it's being initialized here. Now testArray.length. TestArray is in scope of this set of curly braces. Even though it's private, it's accessible. And its length is obviously 3, so I'm just going to plug in 3 like you should do if you were doing this on the AP exam. You can't change the length of an array, unlike an array list, which is dynamic and it could change while this executes. This will not change. It's 3, I less than 3. Okay, increment test array square brackets I. So I is currently 0, and square brackets 0 means go to position 0 of test array, and position 0 is right here, and that's the number 3. So really, I'm passing a 3 to the increment method as a parameter, and the 3 plugs in there to that formal parameter n. So n is local to this very small method, and n is now equal to 3. It's a local parameter. And 3 plus pluses. Notice the collapsed way of typing this out. It's bad style in my book, but it works. And on an AP question, that's allowed. So 3 plus pluses to 4, that's nice. But then because of that closing curly brace, the local parameter n falls out of scope. Its lifetime is over. It's gone, see ya. It no longer exists in the stack of the memory of the computer, as we would say. So all that plusing was for naught, to tell you the truth. It was illogical, but oh well. So we come back down here to where we just called increment, and we proceed to execute the next line of code, which says system out print something. So let's pretend that we have a little output window here of the screen, the console output window, and we're printing test array square brackets I. Well, I is still 0, and test array is still in scope. It's legal, accessible, and its value in position 0 is still indeed 3. So a 3 prints out, and then a concatenation with a blank space. So just for the record, there's a space there. So the plus of n has no effect on this line of code, system out print test array square brackets I. That 3, when it was passed up here to the n, it was called passing by value. The 3, a primitive int, is automatically in Java passed by value, we call it. It is not passed by reference, or like C++, I believe, they sometimes call it passing by address. It is not none of those. It's called passing by value. And it was a bad logical code if the programmer intended to add 1 to something for a long-term effect, because it didn't have that produce that long-term effect. So we already know that the answer 3 is part of the output, and that rules out D, C, and B. And technically, we'd have to keep tracing it to make sure there's no array index out of bounds exception, or just logically think it out. So I would guess that the answer is A if I had to guess and save time here. But I will fast forward here and pretend that I++ is the whole way up to 2. At that point, when it's 2, the value 5 is passed. The 5++ is to a 6. Which has no effect on the output. So that 5 will print out here after some spaces. I++ is to 4, or no, I'm sorry, I++ is to 3. At that point, this control expression is false, and there is no out of bounds exception error this for loop does gracefully stop before it would try to access any out of bounds part of the array. So the answer is definitely A. Okay, so I'm done with number 8. I scrolled down to number 9. Slightly different situation, of course, and we have this array, ARR, and it's got a length of 4, so I'm just going to mark its index positions here with 0 through 3. And now we pass ARR to do something. The method do something receives an incoming parameter. But what is R? What is R really? Do not say that the whole array is passed into the method. That would be ambiguous and inaccurate in my opinion. ARR, when this line of code up here was executed, ARR is an object variable name. It's allowed to represent or reference an array of integers, which technically means it's allowed to store a memory address of where there is, in the memory of the computer, a set of memory that can hold an array of length 4. So let's just pretend that the memory address in the memory of the computer where there's room for this is like A32. So at this chunk of memory, A32, the numbers 1, 2, and 3, and 4 are stored as part of an array. It's a 4, not a 9. And that's the way it is. So a memory reference, A32, is actually what's being stored in the variable name ARR, not this complete set of elements. It's A32. Now, some professors or teachers would sort of draw a pointer to this, meaning that A32 points, that ARR rather, points to the memory address A32. Whatever, I just always record an A32 there as a fictitious hexadecimal memory address. Now, ARR is really A32, so that's what list is as a local parameter in this do something method. So list is really a memory, stores a memory address A32. In other words, it also points to that chunk of memory. And the line of code that we have to now execute, B equals list, B is another local variable being used in the do something method only. B has no role or scope up here, and neither does list. So B, whatever list is, from right to left, this assignment statement, list, B equals list. List is A32, so the A32 reference, as if it were a number, is being put into B. So you would record that B is also A32. In other words, B also points to the memory address A32, which is really where this array, the beginning of it is A32. This 4 might be in memory position A38, or maybe A48, or A52. That's non-consequential to the answer to this problem. It's where the 1 is that matters at memory position A32. So I've now executed that line of code. I did not instantiate a new object. In other words, B is an object variable, and it's just still reusing, like list and ARR, it's reusing that same chunk of memory, that same object. We have one object, but we have 3 object variables in play at this time. Okay, so now we have a for loop. Okay, the for loop has a little loop variable called I. It starts at 0. B.length is going to be 4, so you could cross that out if this were the AP exam. I less than 4. Okay, so when I is 0, that 0 goes from right to left here and plugs into BI. Now the I being in the square brackets just means that B square brackets 0 is now overwritten with the primitive int value 0. In other words, that which is being stored at index position 0 index position 0 is this position, and the 1 that's in there is now crossed out, and this 0 overwrites the 1. And now we loop back up to the top of the loop, and I++, and 1 is less than 4, so we go through the loop again. And at this time, I have to be careful with my scratch work, I is equal to 1, so that number 1 is assigned to the container, the element b square brackets I. So b square brackets 1, which is like this position, this block, that's being overwritten with the number 1. And I think you can see the pattern now. I++ is to 2. That 2 is going to overwrite this 3. I++ is to 3. 3 is less than 4. So the 3 does plug into this position here. And then I++ is to 4. 4 is not less than 4, so this becomes false. We do not execute this anymore. The for loop gracefully ends. We hit this closing curly brace. We're done with the do something method. We come back up here to the calling code segment, the code segment that called to do something. We're finished with that line of code, and we now system out print something. So here's my output window, and ARR1 is this block right here, this element, which currently stores the 1. So a 1 prints out because of that. And because this is print, and we have a concatenated space, and even though this is a separate line of code, because that was a print, ARR3, which is this chunk of memory, which is currently a 3, that prints out to the right of the blank space. So the number 3 prints out, and we end up with 1 space 3. That's it. We're finished executing the code. The answer to this exercise is definitely C. Moving on to the last exercise in this batch, exercise number 10. Here it goes. Okay, exercise 10 on this worksheet. Another interesting one that has to do with possible array aliasing. Let's trace it. A method in the same class calls getData. So if you're in the same class, you have access to any private stuff. Just making a note of that. And the first line of code that we have to consider here is an object variable array, named array, that's on the right-hand side of the equals here. There's a new array of integers being instantiated. So somewhere in the memory of the computer, a new array of length 10. I'm just going to do a ... there. And if it has a length of 10, that means that's position 9, and this is position 0, and it's 0 through 9. ... Now, when you declare a new array of integers, you get free zeros placed as values in the elements of that array. So that would be correct if you annotated that on your scratch paper. So we're not quite finished yet. The computer tells you what memory address this lead element is stored in, and I'm just going to pretend that it's memory address A32, which technically just means that the variable named array stores the memory address, the memory reference A32. So in other words, array points to this actual object. Okay, so we've now executed that line of code. Now we pass array as a parameter to get data. So really the memory address A32, or some memory address that's unknown to us, but it doesn't really matter. Just know that a memory reference is passed up here. So list, which is a local parameter, is a parameter that points to an array of integers. So it points to this object as well, just like array does. And we execute the line of code system out print ln enter 10 integers. So don't really worry about that, but on the output window somewhere, there's a nice little prompt message. And the next line of code is the interesting one. List equals new int, square brackets 10. The new operator in Java tells the operating system to go find a chunk of land, a chunk of memory, where there's enough space for 10 contiguous consecutive integers. So it finds some spot that's not being used by Facebook or Instagram or Snapchat, some other program that's running on that device, and it finds a chunk of memory. Now this might be some arbitrary memory address like say B52, some hexadecimal number I just always put there. So that's really where the object that is this new array of length 10, that's where it is. And there are zeros put in there, just like I put zeros in earlier over here. I'm putting zeros in because of, okay, I already did that. I'm putting in 10 zeros here, just to show accurately what happens behind the scenes. And the parameter name list is now being overwritten by whatever memory address the operating system just found space for this object. That memory address, B52, is being assigned into the parameter name list. That's kind of what happened up here. A32 was assigned into the object variable name array. Well, the same thing's happening here. List is being overwritten with the A32 that was passed as a parameter up into this method. That B52 is overwriting that, and no longer does the variable name list point to this object. Intuitively, this parameter, this variable, points to B52. So the use of new broke the aliasing that was occurring with two things pointing to the same thing. Both array and list were aliases for this underlying object, but that's broken now, and only array points to this. List points to this. Okay, next, the line of code. Whoops, I'm sorry, that's not where I was. This for loop now executes, and you're supposed to assume that there's some readInt method in some fictitious IO class that only works for this exam question. And you're supposed to assume that I goes from 0 to 9. Of course, it hits 10, but it exits the loop at that point. And into all 10 positions of list. In other words, list, which is B52, which means that we come down here, all 10 of these zeros will be overwritten with interesting numbers that the user inputs. It reads user inputs. This line of code, read user input. So we just make up fake numbers like 3, 5, 6. We're not guaranteed that they're positive integers here by anything in the question. So they could be negative numbers. I'll throw a -5 in there just for fun. Maybe big numbers like 1,000,000 are put in there. It probably would not, they would not do numbers like 3 billion because that would cause overflow. You're just supposed to assume that probably. So that's what happens because of this for loop. Interesting numbers are, I'm sorry, I was right here. Interesting numbers were put in the list. Now, list falls out of scope. Once we hit this curly brace here, list is no longer legal. And I have to clean things up a little bit here. We are currently in this exercise, we are currently back now down to this for loop that it would execute. Currently, I'm executing this for loop for the first time in this exercise. I is a loop variable, just like the I up here was local to this for loop. This I is local to this for loop because of this int. declaration. And anyway, so that I is bye-bye, see you later. It no longer exists. But there's another I, and it starts at 0. And we are now system out printing array I. So that I is currently 0. Array, which is currently storing A32, which tells me to point my eyes down here. In position, square brackets 0 of the object at A32 is a 0. That's what it is. It's not this interesting number 3. That list fell out of scope. It was garbage collected by Java, and that point no longer exists. You don't even say it points to something else. This is totally gone. There's no memory of that in the memory of the computer. There's no history of it. Forensically, I don't even know if the FBI or the NSA could retrieve those numbers. But these zeros are still here in A32, etc., which is indirectly an array. So a 0 prints out in my output window, a space, and then I++ is to 1, which means array square brackets 1 prints out, which is this 0, which then I++ is to 2. And you can see the pattern now. Because I is currently 2, that which is stored in square brackets position 2, this 0 right here, prints next after a space because we're making it nice and readable. So the answer to this exercise, you can already see this coming, the writing on the wall. The 10 integers entered by the user will not be output. They are long gone. They fell out of scope. They're garbage collected, something like that. That's gone. And distinct integers different from those entered by the user is not outputted either. That answer is not even relevant or close. There is not a null pointer exception here. Any object that was referenced was in scope and instantiated at any point where it was made use of. So that is not an answer. And none of the loops here involved are going out of index. The I++ and the 10 here and the 10 here were correct, and that is not an answer. Nope. The answer is B, as you have already seen with the pattern, 0, 0, 0, and we'll end up with 10 zeros spaced out with blank spaces. So the answer to this exercise is definitely B.